So can I take water for 1 minute? Let me just get water. 1 minute.
Okay.
Just 1 minute I want to get some drinking water, please.
Mm-hmm.
I am back. Sorry, I'm back.
Okay, fine. Okay, most of the classes, good to know that, Ashish. So most of the classes we have covered only the basic part, like we have gone to the introduction, syntax, comments, variables, data types, numbers and strings and booleans. So far these are the basic things, and there like today I'm going to discuss like a few more things like called operators. So it is very important when you deal with some sort of numeric data. Okay, so it plays a very important role. So I will directly jump into them and I will start. And I already mentioned in the previous session that we are going to discuss on operators and list. So I think today we can cover only operators. Let's see if we have enough time, we can go to the list. So Festus, do you have any thoughts in the previous sessions, like in the strings? I think we discussed last class strings.
Yeah, remember I told you it's the last class that I've not watched, but I've watched every other one, just the last class. I wanted to watch it this weekend, but I was too occupied. But I'm
Okay,
the
no
last.
issues. Just take the screenshot and go through this session and try to just revise all these concepts. That's it. Okay. So basically, operators plays a very important role when you try to you want to deal with any numerical data. We have like almost 7 to 8 kind of groups, or you can say types, that has been divided in Python. First, suppose if you want to deal with like some mathematical operation, right? You want to add something. This is the one of the example. So use here plus operator over here. Most of you guys know about it. This is the very basic thing, but still, if you go further, we have some different concepts we will discuss. But the first concept here is arithmetic operators. Okay, arithmetic assignment, comparison, logical, and identity, membership, and bitwise. So up to here, these are all important. And bitwise, we use it very rarely. It's not, we don't use like, very common, but all these operators are very, very important. So let's see the very first one, arithmetic operators. So arithmetical operators are going to deal with numerical values to perform some common mathematical operations, right? Here I have taken one example, x and y variable is, I have assigned 10 and 100 value over here. This is the very basic addition operator, okay? Can just directly, you can add two same data type. That is nothing but numeric data type, right? Ultimately, you are going to add numeric. For suppose you are going to use plus operator for the strings, it is going to concat. If you remember, I have discussed this in the last class. So plus operator plays like a concatenation, adding two strings in the string data type, okay? But coming to the math, like numbers, it is going to add to the perform some mathematical operation. So if you try to subtract like 10 plus 100 is going to be 110. Then x minus y, we will get 90. Next, x asterisk y. We are going to multiply 10 into 100. It is going to be 1000. So at the end of the session, we will do one small program. So we can apply this arithmetic operations into that arithmetic operation and assignment operation. So we are going to combine these two operators and we do one program. Okay. So this is the division. Of course, we're definitely going to get the, this is what, float, right? This is the float one. So here we are dividing integer and integer. We are getting here float value. And this is the modulus symbol. When you, it is going to perform as it is, but here it is returning the quotient. This is the quotient, right? I hope you guys know the basic mathematical concept. So, and here we are, it is getting the reminder part. Are you getting this one? Testers. Hi, Inka.
Yes.
Okay.
Hi, Ayat.
Hi. So basically, what we do, like in our childhood, we used to do like this, right? This is like divisor, dividend, quotient. So when you do, this is the division operator, we are getting like, did I do anything? Sorry, this is 100, this is 10, okay. And here we are getting 0.1, right? So 0.1 is the quotient here. And when you try to use modulus operator, you will get the remainder here. You get remainder 10. So that's what we are getting on. Next, double asterisk. If you use single asterisk, it will multiply. If you use double asterisk, it is going to be the x to the power of y. It's like 10 to the power of 100 here, okay? And we got some very big number. Let's take very small number, right? Let's say x equal to 2 and y equal to I comma 3. So if we do like, so we should get 8. So this is called exponentiation or y to the power of x to the power of y. And last one, but not least, float division. Division and float division. The difference is it is doing the same, returning the quotient part, but it will return complete float, okay, including the decimal, but it will return only the whole number. Okay. Any doubts over here? This is up to arithmetic operations. Okay. So next, let's see about the assignment operators. So from the beginning of the Python classes, we are doing something like, we are declaring variable, we are assigning some value. So it is also the one of the concept in Python operators called assignment operators. We are going to assign one value to a variable. So that is called assigning a value to a variable. If you see, I have assigned a value to the variable A, and it has stored 5 run is, we are getting 5. So this is one of the operation. Next. So this is like a very short form assigning A press equal to 5. And it is similar to A equal to A plus 5. So most of the in Python code you're going to write like this. You are not going to write like this. Yeah. For suppose I have written 10. It is going to be 10 plus 5, 15. That's how it works. The same goes to subtraction as well. If I try to split it A equal to A minus 5, but if you want to write in shorthand, you have to represent like this. What it will do, 15 minus 5, we will get 10. Okay. Next, we have seen the value we have assigned, then after addition, subtraction, next. Then we are going to multiply with the number. Right now we have 10 in hand. So if I try to multiply, we will get 50 over here. Okay. So the same thing. Here you can see, here we are combining the two concepts. Previously we have seen arithmetic operations. Now we are assigning the now we are assigning the value. Simultaneously, we are doing some operation. Here we are like normally doing two operations, assigning and operating as well, like some arithmetic operation. Next, division. So we are having a 50. If I divide by 5, we will get 10. What we will get? 10.0. Next. So modulus. So if I divide by what I will get, I should get the remainder as 0. Guys, are you understanding this concept? Just like very basic thing. I hope you are getting.
Yes,
If
yes.
you have any doubts, you can ask. So the same thing goes here, modulus, the same goes for the floor division. So right now we are having 0, right? Let's take it as 100, okay? So 100 divided by 5, 20. So I should get only 20, not 20.0, something like that. That's how floor division works. So let's say I have taken number 6 over here. So this is asterisk, right? So it is going to perform power exponentiation. So 6 to the power of 10. How much it is going to be? It's like, yeah, it is going to be the big number. So like, the simple concept followed by some other concept. Then after we are combining two different concepts. So next, here you're going to have some sort of, you can say, confusion and all. So it's a bitwise operators. It is a bitwise AND operator. So let's say I had taken the number 4 over here, okay? Equal to 4. Basically in computer language, we have different types of number systems. So I don't know, you guys are familiar with the number system concept. So number systems. Basically numbers are represented in the form of like decimal, binary, octal, and hexadecimal. Okay. So basically for decimals, you have the representation up to 10 digits, like 0 to 9. For binary, you guys already know only 0 and 1, only two numbers. Octal, it's 8. And hexadecimal, it's almost 16 numbers. 0 to 7, and octal starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And for 10, it is represented as A. For 11, it is represented as B. For 12, it is represented as C. I mean, if you have seen any code representation like ASCII or something, we have different kind of hexadecimal formats. So data is represented in the form of these 4 kind of formats, okay? D and 50. Okay. So when if you don't understand, it's okay. But generally, what happens right now? Whatever you are seeing, this kind of big number, it's just called decimal number system, okay? And in order to understand this concept, bitwise AND operation, you have to understand how this will happen. Okay, so I will give an example and let's understand with that. So let's say I have taken number 4. So this number is called decimal number, okay? So I have mentioned it above, right? Decimal number. 4 is the decimal number. For decimal number, we have some other representation in binary. For suppose I want to represent this in binary form. Binaries are 0 and 1s, right? So how I can convert decimal number to binary? What we will do, we'll just try to divide by 2, because for binary we are having 2 numbers. We are going to divide by 2. So 2 2s are 0, and so we got 1 0 0. For 4, binary representation is like this. If you want to see that we have did the correct division or not, what you will do, you will try to multiply with 2 again, because it will start with right hand side. So we will try to give like 2 power 0, 2 power 1, and 2 square and 2 cube. If you multiply here, 2 to the power of 0 into 0 plus 2 to the power of 1 into 0. If you see here, I hope you guys are understanding. This not going beyond the, concept. Hello?
Yeah, we need to follow him.
I think I think you know about this because you're working in networks, right? You know about binary, all these things.
Yeah, I know
Yes.
about the binary.
Yep.
But this one, the way I know the binary side, but still trying to see how. Okay.
Yeah. Hillary, can you mute yourself? So yeah, that's what I'm talking. This is the binary representation. So in Python, when you want to do some sort of operations, this is one of the AND operation. So in order to do it, we need to get the numbers into binaries from the decimal number system. Okay. So for 4, I got. So here I want to do AND operation with 3. So for doing 3, I need binary for 3 number as well. So how I can get it? So the same procedure. We can directly do it or we can directly find it. Actually, there is no need to do anything. Python will handle everything by itself. So it's just like you need to understand. That's why I'm telling you in detail. If you write binary and if you write it bin 3, it will give the your binary number over here. So the binary number is for 3. That's it. So here it is going to perform AND operation. So what do you mean by AND? What do you mean by AND operation is? So what happens? We are going to have some sort of truth table, okay, for performing AND operation. 0, 1, 0, 0, 0, 1, 1. So when you have 2 ones, it is going to return 1. Otherwise, everything is going to be 0, 0. So here 0 means false, 1 means true. Likewise, if you see this table, to this table, you can complete this particular task. So 0, 1, we will get 0, 0, 0, 0. Ultimately, we will get 0, 0, 0, 0. Let's see what we will get. We're getting 0. So that's how bitwise AND operation performs. Okay. Next, likewise, we have bitwise OR operation as well. How we can do OR operation? So likewise, we had truth table for AND, right? We also have, this is called TT, truth table. Let's see, let's say XY values, okay? 0, 1, 0, 1, 0, 0, 1. So for operation, what it happens? It is going to return 0, but remaining it will take 1, 1, 1. False, true, true, and true. First, suppose let's take x equal to 4 and y equal to 3. So for binary, this is the binary, right? This is for 4, this is for 3. So what we will get if we perform OR operation? We get 1, 1, 1. So if we want to convert this into decimal, so this is like 1, 2, 4. This is 0, 7. Let's take this 4 and let's take this as 1. We got 7. Any doubts in this? See, we got the binary number. That's what we did here, right? So that is what bitwise AND operation or operation, and we have one more call. So C caret equal to 10. This called bitwise OR operation, XOR. So this is XOR operation. Okay. Same here, also having truth table. Now after this session, check out on the Google what these operations are, how it happens. So let's take the same example of previous examples. Okay. 0, 1, 0, 1, 0, 0, 1, So what will happen in XOR actually? It's like, so what will happen here when two numbers are false or true, we will get false. Okay. When any one of the number is true, we will get true. That's what it happens. So let's take for 4 and y equal to 3. X equal to 0, 1, 0, 0. Y equal to 0, 0. Right? So in terms of XOR, what we should get? Here we should get 1. Here we should get 1, 1, 0. Right? That's what we should get. We got 4. So what was the issue? We did anything mistake over here? Yeah. So let's see the truth table. You can find like this exact truth table for 2 inputs. See, if you see over here, for false and for 2, it is returning false, but 1 true and 1 true, it is returning true. So anyone can figure it out what's wrong here? Actually, we need to get 4, but we are getting 7. That is wrong. Ashish? Okay. Ashish, anyone can let me know? Because you guys are know this concept.
What was the question, please? Sorry, I was a little distracted with work here.
Okay, like I will repeat it. Listen. See, I was discussing about this one, right? And or right. Likewise, we have XOR as well. This is the truth table of XOR operation. So if you see here XOR operation, for 2 false and for 2 trues, it is returning false, and remaining any one of the true, it is returning true value. Likewise, I have given one example over here. X equal to 4, this is the binary number, and y, this is the binary number, right? So I need to get 4. So like, let me check. C is 4 and this is 3. It is returning. Okay, my bad. It's wrong. So what is going, is it 4 or is it 7? What do you think? What will be the answer over here? Can you tell me the binary of this particular result? Do you understand what I'm asking? Just based on this, truth table, you can just directly apply. See, only 1 true and 1 false. We will get 1. We will get 1. We will get 1, 0. So it is going to be 7. So I hope you got it. That's what I was asking actually.
Yes, I got it now.
Yeah. So if you don't understand, try to do it by your own. You will understand. Otherwise, we will discuss. So next, another concept is shift. just got like greater than symbol. It seems to like greater than symbol. When you have two greater than symbols, it's like we are shifting some binary digits to the right side. The positions of the each bit number is going to change. So the meaning here is each right shift is going to shift by 3. What do I mean by 3? So let's do some example. Let's say 3, okay. For 3, what is the binary? 1, 1, 0, 0. So let's take up to 8-bit, okay. This is the 8-bit binary number for 3. For 3 decimal number. So when you represent or when you see anything like this, it means that you have to shift 3 binary digits to the right hand side. So the 3 positions from the right hand side is going to change. So you're going to change one by one, okay? First, suppose, let's say the first position is 3, right? Let's say 3 positions. So this particular one is going to shift towards here, okay? When it is going to shift towards right, this all 7 numbers is going to be like this one particular 0, because we have shifted one position right, we will get this particular number over here. So if you see, if you try to here just like 1 0 1 1 0 0, right? So when you try to shift one position over here, you're shifting one over here, right? So what here is going to be 1 0 0 0 0. So it is not going to be 3 anymore. It is going to be 1. Okay. So you have shifted one bit right. Next, we have to shift 2 more. Then what you will do? Next, you will shift 1 over here, and you will lose 1 this one, and you are going to have 0 over here. 0 0 0. Okay. From the next time, you will see only 0. The complete number is going to be 0. So when you're going to shift again, it's going to be 0. So that's what it happens when you see 2 1, means you have to shift one position right by bit 1, okay? So first, suppose if you see, let's say C equal to 3, okay? I told you, right? You will get only 0. So that's what it happens. Basically, in short term, if I say what is happening, is going to divide the 3 number by 2 to the power of 3. 3 divided by 8. That's what it is happening. Understood this one? Right shift, bitwise right shift. If you did not understand, I will take one more example and I will make you understand. Ashish, remaining देखो, who are there? Hello.
Yeah, we here.
So you have understood that concept, right shift?
I need to watch the video again.
Listening, but it's complicated. But go ahead.
I mean, if you want to watch the
Is
video,
it complicated?
Go ahead. I'm looking at.
Okay. All right. All right. Okay. Likewise, we have the right. We have left shift as well. So we have changed the position of the right side, and then we are going to change the position of the left side. So let's take one example and let's discuss it. The way we did it the right side, the way we are going to do it the left side as well. When we talk about the right shift, is going to divided by, I have taken this one, right? This is the right shift. That means 2 to the power of 3 means 8. So you are going to, let's say I have taken number C equal to 3. This is going to divide by 8. That's why we got 0 over here. Then when we're going to do left shift, we are going to multiply by 2 to the power of 3. We are going to multiply by 8. So 8 into 3, we should get, 3 is a 21, right? We should get 21 decimal number. So okay, let's take D equal to 3. So when I try to do left shift by 3. Sorry, 8 3 is 24. My bad. 8 3 is 7 3 is 21. So every time when you try to multiply, it is going to be a double. Okay. So that's what it happens. So let me tell you what is happening here. So let's take 8 bit, okay? So previously we tried to shift right side by 3 positions or 3 places. But we are going to do same thing from the left side, 3 positions. So these 3 positions is going to get shifted. Then we are going to have only this number. So this number is going to be like 1 1. Then we are going to add remaining zeros, or we are going to pad with the zeros. That's it. Next, we are going to have okay. So when you are going to multiply, so this is going to 2 to the power of 4. So almost 16 to the power of 3, 8, 24. So that's why we got 24 over here. Okay, just simple thing. When you are going to do light shift, shifting by 3 positions, or else directly dividing by 8. When you're going to do left shift, shifting the positions from left side, 3 positions, or else multiplying by 8. So that's what we are doing, right shift and left shift. So this is all about assignment operators. So far we have discussed arithmetic operators, assignment operators. Now we are going to discuss comparison operators. Okay. First, suppose you want to compare any 2 numbers or any 2 certain kind of strings, we can use comparison operators. So it's like basic operators like equal, not equal, greater than, less than, greater than or equal, greater than, less than. So it's like a very basic thing. Okay? So if you see, I have taken A, B, 10, 5. So when I try to compare with equal operator, it has to return false. That's what it got, false. Okay. Next, when I try to compare with not equivalent operator, I have to return or I have to get true. Okay. So when I try to compare with greater than operator, I have to get true because 10 is greater than 5. When I use less than operator, I have to return false because 10 is less than 5. That's not true, that's false. Okay. So we have two more operators, greater than or equal to or less than or equal to. So let's say I have changed it as. So here it has to return true. Here it will return true because I have changed the numbers to 10, 10, right? 10 is less than or equal to. So one condition is getting satisfied. That's why we are getting true. Here you can see, here two conditions are checking out. One is A less than B and A equal to B at a time. And A greater than B and A equal to B. So this is comparison operators. Next one is logical operators. So whatever I have discussed about the truth table right here, and or XOR. So this particular and or XOR. So in Python, we have keywords like and, or, and not. So mostly we use these three operators only, logical operators in Python. When you want to combine two conditions and check it out, you want to validate something. For suppose I have taken 100 over here. Okay. And I want to compare with these two conditions. We can use AND operator over here. So it is returning true as 100 is greater than 90 and 100 is less than 110. That's true. Next, the same goes with OR operation, the same goes with NOT. See what NOT is. If you guys remember, we have discussed at the starting class itself. I have used NOT operator in strings. Once you get familiar with this, we can use in, and you can combine with strings, we can combine with, list, we can combine with tuples, we can combine with any types of data types. Doesn't matter. The use is going to be the same, but the type of data you're using it is going to be different. So if you see, I have used AND operation, then after if you want like opposite result, we can use NOT operation. It will try to do, if I run here, I got false. Want to make it true. So that's how NOT operator helps. So these three comes under logical operations. Okay. One more important concept, identity operators. So basically identity operators, what it does is, it will try to check two operator objects are located in the same memory or not. See, here I have given one example. X, I'm storing the Queen Charlotte, and I'm storing the same X value to the variable Y. So it will definitely going to point the same memory addresses. Let me run. If you see here, see, it is going to point the same memory addresses. So what is operator does, in order to check the two objects are storing in the same memory location or not, we use is operator. it will point the memory location. So right now in this particular example, it has to return true. It has written true. And there is one more operator called is not. For that, so if the two objects are not showing the same memory address or not in the same memory, it has to return true. For A, I have written hi. For B, I have written like some different string Ola. So it has to store in different memory locations. Right now, for this, definitely it is going to be what? True. So this is what, in some cases, what happens? There is one concept called oops concept. This is kind of some advanced concept in Python. When you go through that concept, this is operator, is not operator, you will use in further cases in order to identify that that particular object is pointing the same memory address or not, to store or not. In that cases, you will use this identity operators. Okay. So one more concept, Python membership operators. So these membership operators we have seen in previous cases so many times, in and not in. First, suppose if you want to see any one particular element, object or something in some other variable, you can directly use in operator in order to validate or check it. So if it is there, it will return true. If it is not there, it will return false. Okay. So here banana is in the list, is returning true. And grape is not in X and it will return true. It has to return true. So these are the concepts of operations. So that's all up to here. We have like one more operations like bitwise. Bitwise is same like whatever we have seen over here. You know, right shift, left shift, and operations. So try to explore that it is similar. So even if I discuss, it is going to be the same thing. So just try to explore this concept. Okay. So that's it. So we can end over here, today, and I will discuss the list for the next session. So if you have any doubts, so I'm here for up to 5 minutes. You can ask about anything up to Python. So far we have whatever we have discussed. If you have any doubts in this particular concept, you can ask me as well. I will do one thing. I will share this notebook, or I will try to upload in that particular folder. You can use this notebook and you can practice it.
Okay, thank you. Well, we'll look to the video. If I have any doubts, I will let you know in the next class.
Sure. So next classes is going to be like a little bit more, advanced. Like we are going to jump into the concepts. So we are directly going to jump because all basics part has been covered so far. We are going to do the things. So that's all up to today. So if you don't have any notes, we can close the session right now.
Can I just send the recorded video I asked?
Sure.
All right.
We will share. Ashish, you can stop the recording. Okay, then let's see for